So there's a couple little technical snafus on this thing, so if you don't mind bearing with me for just a second. Come on. I'll shut this down again. Okay, so how y'all doing? Yeah? Okay. Guys excited for our last class? That should be a no. Why is everybody smiling? Yeah, but that wasn't the question. That's cool. So, we have a few little snafus on our technology bit. We gotta get the screen down, we gotta get the computer projecting. It will be shutting down and rebooting. And so that's cool. We have a little bit of time to do that. And as that goes, we will touch base on a couple aspects of things. So it's nice to see so many of you guys again after a nice long weekend. First of all, do you guys have any questions for me? No? You guys all feel good?
I was thinking.
Good. Good start.
Yeah. Regarding the presentation, is it usually graded by the end of the presentation day?
Usually.
Yeah, just making sure. Thank you.
Yeah, so we have one left for today, is that correct?
Yeah.
Are you guys ready?
Yep.
Okay, we'll do it towards the end. Does that sound good?
Mm-hmm.
Okay.
Is that still a quarter of our grade?
It will be whatever the syllabus said it is. I forget what the details is off the top of my head, but that's why I wrote it down for the most part. So
I know we got rid of the questions, so I was just wondering if it was
Yeah.
going to be way less or not.
It won't be way less. And in fact, hopefully nobody has complaints about that
No, not at all.
So basically,
because it works out to your benefit. Yeah, okay.
Okay.
Yeah, it's designed to benefit you guys. Unless, of course, there's dissent in the masses. I'm happy to revisit. We're good? Okay. Any other questions? You're good?
Yeah, I'm good.
Okay, keep thinking. That's a good start.
Yeah.
All right, so I'm going to do a lot. I'm going to, just as we started off talking about this whole semester, I'm going to try to cover a lot of material today. So it's been, we've hit that mark, have we not? I promised. Did we not deliver? Covered a lot of material. Okay, good. So we've just about wrapped up our book. I hope that you guys have liked it. Have you guys enjoyed the text? Okay, I've tried to stay as faithful to it as possible for the majority of class. Of course, we deviated and added our own things at the beginning of the semester, and I'll do that again today. So I'm going to be adding not just stuff about the text, which if you guys read the assigned content for I believe it's chapter 17 and 18 for today. By the way, chapter 19, which is the last one on the book, will not be on the exam. So, mental note there for you guys. So, but chapter 17 and 18 will be alluded to certainly today. But what we'll do is I'm going to build from that material under the assumption that you guys have set the foundation of reading that that base assignment, and I'm going to add to it from things that are not in the textbook, that are newer and arguably cooler and more cutting edge than our 2014 textbook. Okay, so I'm going to share a little bit with you about some of the work that's coming out of my lab on the related topics, as well as some other laboratories that are working collaboratively around the world towards a lot of the same questions that chapter 17 and 18 were addressing and sometimes just raising. Because I think what's really cool is that we don't also often have answers to these questions, but the exciting part is that they're being raised and asked. So that's one of the things that I hope to underscore through the course of this semester. Okay, so let's dial this in. Okay, so like I said, we will cover a handful of material. I think it's new and exciting, and I will be moving fairly quickly unless you guys slow me down and ask questions, slow me down in a good way, that is, and say, whoa, 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 dude, you're way too fast. Let's break this down for a second. In which case, as you guys hopefully know by now, I'm happy to break it down and slow it down, and we'll slow jam the news if we need to. Okay. So I'll be covering a lot of that stuff. After we do that, of course, we'll have our last and final presentation, and then next class will be the exam at the testing center. So make sure you guys go online and reserve a seat and do all that kind of good jazz as we're on the syllabus towards that end. And let's see here. And we will do that, and grades will be posted as soon as I can afterwards. For the most part, I've been really impressed with how well you guys have done. And so it kind of leads me to the last couple of things I wanted to end with, but I guess in this case, for our ending class, I'll start with it by saying thank you to all you guys for all of your dedicated hard work and patience and attention throughout the semester. I started off the class by challenging you that we were going to cover a lot of material in what I hope was a fun and interesting and engaging way, but in a way that was also challenging and difficult too, by intention. But hopefully you guys may have realized that if you did the difficult work of preparing and studying and doing your job, that hopefully you found the exams are very accessible and manageable in that capacity. So that's usually the kind of format and paradigm that I try to utilize in classes, where if you guys do the hard work and preparing, hopefully the exams are very accessible and manageable in that regard. So I think you'll find that in a lot of regards in life too. Most of you guys are already very successful people, very successful students. So you guys already know a lot of that information, hopefully from your own walks of life, and that all the things that you've really prepared for well, when you go into those tournaments, you go into those competitions, you go into those presentations, they tend to go pretty easy at that point. So hopefully this course has provided another means of demonstrating that and practicing those skill sets. So I'm very impressed with all of your work. I think it's been fantastic. I think you guys have done a really great job. And I know that this wasn't necessarily an easy class, and we covered a lot of complex topics that I've done my best to break down in a very simplified way. But at the end of the day, they're pretty complicated stuff. We dealt with a lot of crazy, weird acronyms and weird ideas and maybe stuff that we haven't had before. So, you know, I want to tip my hat to you guys in acknowledgement of your work there. Let's see here. My goal was to not teach you, but to guide you in your own teaching. And hopefully I could have been a guide along that journey for you guys. And that, you know, guide you to your own learning such that, you know, not to do your learning for you, but to help you achieve that in your own realm. So that's one of the big things that I'm very impressed with you guys upon, for having assumed that autonomousness, which I think is one of the hallmarks of what we should be getting from our college educations, is being guided towards that autonomy. Because certainly if you guys go to medical school, graduate school, business school, law schools, it's going to be a fundamental feature of any success that is going to be requisite, is having that autonomous ability to learn independently from things outside of class and that aren't necessarily said or specified in lecture. So I sought to give you that autonomy in your learning and to foster that appreciation and wonder, not just of what we do know, but also to underscore an appreciation and wonder for all more so of the things that we don't know yet, and to encourage you guys to embark on those explorations to discover some of those things that we don't know yet, which is just about everything, hopefully, is the framework that I like to present things in. So it's been a real honor and pleasure to have been your guide along that learning journey and to share with you a little bit of what I know about learning and memory. So I'm always here for you guys as a reference for material. If you guys have questions about anything you see in the news, cool articles, cool papers, cool questions, something comes up in a crazy late night bar room discussion you're having sometime, shoot me an email. It's rdante@gmail.com. I'm faster to respond there than UTD because I get less spam. So I'm a resource and a reference for you guys in that regard. So if any of you guys need references for anything more tangible, medical school, graduate schools, I'm happy to provide my best support for you guys towards that end as well. So please stay in touch, and I'm be delighted to hear about all of your respective successes, and that'll be very exciting. Like I said, I'm basically, was hoping to provide sort of what you might consider real learning. What I mean by that is basically not just fostering a regurgitation approach, but actually fostering a synthesis and understanding of that material instead. And that's how we've tried to test, and hopefully you guys have seen that, and you guys have done a resoundingly well job in responding to that. So very impressed. You guys should be very proud of yourself. Hopefully you guys feel good and exhausted at the end of the semester. You know, you should be refreshed in the sense that hopefully you've prepared everything so you're not freaking out and crazy for our final at least. Can't account for the other classes. But I hope that we've exhausted you sufficiently in a good way through the work and readings required for the class. Because that's kind of also how I see our position, is, you know, being obligated to challenge and push and stretch, because that's where real progress and growth is made, when we're kind of stretched a little bit beyond our comfort zone. So again, I've recognized you guys have done a fantastic job with that, so I want to thank you and acknowledge that as well. And kind of finish on the note that, you know, our brains have a remarkable ability to learn and remember. Hopefully we've learned a little bit about that in this class. But, you know, I hope that we have basically been able to engage that ability to learn and remember successfully, such that you will remember what we have learned. And hopefully apply it in the way that we started off talking about class in terms of cognitive strategies. Because indeed what we're tasked to do, either in our jobs or our school or education careers, is indeed to learn and remember. It makes a fundamental component, not just of our professional success, but as we've learned from clinical cases like patient Clive-Wearing, patient HM, and all the other patients that we've talked about, really a critical and fundamental aspect of our lives in terms of just basic humanity of our interaction with others and our families and friends, and the things that we consider maybe not frequently enough as the basic elements and fabric of our lives, I would humbly submit. But I'm biased, I'm a memory researcher. So I will finish off talking about some new ways of looking at memory that integrate some of the old established traditional models that we've now began discussing. We'll talk about some of those models and then where some of the directions the field is moving in the future for those of you guys who are interested in more further research and additional information. This was just an introductory primer of a class, and I'd recommend Mike Hasimo's book. Is a great book on more advanced aspects of memory, particularly neurobiological and cognitive mechanisms and network level. It's a really simple, easy read. It's not even really a course textbook. It's a reference book. It's only about this thick, and it's a pretty good read. So that's Mike Hasimo's book. I believe it's called How We Remember, Mechanisms of Episodic Memory. Highly recommend it. Very good if you're interested in this type of thing. Ian Neath has a book with Amy Supreman. I think we might have some chapters for that posted on e-learning, but that's a very good cognitive book. It's also what I would consider a graduate level book on some of those topics. But if you're interested in some of the cognitive stuff and theories and mathematical approaches, that's a really good resource too. I'd recommend. And in the future, if you're interested, you can certainly things I hope to integrate in future classes are aspects of exercise and its role in cognition and the role that neurogenesis plays in supporting each of those. There's really cool aspects of sleep, nutrition, stress, even the role of distraction in actually reducing memory and the other factors I mentioned a moment ago in terms of augmenting it. So there's a lot of really cool stuff yet to be discussed because we don't have enough time. So I would recommend those efforts to you on that regard. And on that note, it looks like this is all ready. Let's see. And okay. So I am going to shoot for about 30 to 45 minutes. That means I'm going to skip over some slides. Don't worry if I go too fast. If you have questions, by all means flag me down, tell me so. But I'm going to try to pick some of the more relevant aspects. We can get this guy up and running. Ooh, laptop. Put the screen. Yes, okay. So, and again, this is going to be material builds upon, God bless you, the chapter discussions in 16, 17, and 18. So hopefully you guys have done your job and coming prepared with having that information in your mind, and if not, you can revisit it after our talk today, and hopefully some of the ideas will be woven together for you. Okay, so let's see here. I don't have my pointer today, so I'll have to do this by hand. Okay, so we're going to talk about a little bit about brain states for enhanced performance, and particularly in the context of performance, I'm talking about cognitive performance, and particularly in the domain of memory. Now, you can look at that in other ways. You can talk about enhanced cognitive performance for attention or other stuff. Obviously, this is memory class. We're going to talk about memory. So we'll talk about the role that curiosity can play. We'll talk about pre-existing brain states, and they're related to basically successful and unsuccessful memory. We'll talk about how we can then tap into that, and then I'll finish off with some of the strategies that we've already introduced in the beginning for people to take forward to succeed in their learning and memory, because of course you guys need to learn and remember stuff for your upcoming finals week and whatnot. Make sure you sleep well, get rest, get a little bit of intermittent exercise, eat some good nutrition. All right, got all of those PSAs out of the way, because it's not trivial. That stuff actually does matter. So let's talk about some ideas then that we've already broken some ground with in addressing earlier in class, and certainly in referring to some of the chapters in terms of semantic memory. So I would like to introduce you to somebody who thinks they're somebody is very near and dear to my heart. Okay, so if you don't mind, please meet Juno. Okay, she truly thinks she's a human. She's spoiled rotten. She's our great 2-year-old puppy. Okay, she's a little greyhound mix. We found her, well, somebody found her mother on the street somewhere from a greyhound rescue, and turns out she had puppies, and we have Juno. We don't know her daddy. I think her mom got around a little bit, and but she's a great dog. Okay, she's like a lot of dogs. She really likes to play and roll around and goof around. She likes to run on trails. Okay, she loves swimming and long runs on the beach. Okay, this is White Rock Creek for those of you local Dallasites. You got to be careful out there. There's every now and then you get a few snakes and animals, but she loves to run around there. She's chasing a duck all the way in the back left over there. So she loves that, like most dogs. Okay, she loves to travel, likes traveling in the open road. Okay, when she was a little puppy, when we first gathered, she used to like riding shotgun. She was a little bigger. I don't want to get out there. Okay, but as she's growing a little older, like I said, she's spoiled rotten. She thinks she's human. Now she prefers to drive. Okay, so you know what I want you to do is use these examples to actually tap into this concept that we'll talk about in the terms of the delineation between episodic memory and its semantic memory. Okay, so imagine if you only had memory for those sentences. That is, Juno likes to play. She loves swimming. Sometimes is lazy. She likes to travel. Likes the open road. Riding shotgun, prefers to drive, yada, yada, yada. If you only remembered those things, but you didn't have the pictures that provide the rich weaving and context of our episodic experiences, our abilities to do what Endel Tolvin, a really, really famous memory researcher, refers to as mental time travel. Right? And if we couldn't do that, we would indeed be what you might consider amnestic in a lot of ways. And certainly it alludes to the aspects of patient HM in some regards. Okay? So, we didn't have those rich, colorful tapestries woven into our fabric of what we can retrieve. Okay? And what it suggests is this idea that we talked about in the text, and that I'll build upon again, is basically that these semantic memories, that is just the information for facts and world knowledge and general information, right? They do very little to enrich our lives. Okay? Nor do these semantic memories actually weave those rich tapestries that, on the other hand, our episodic memories are critically involved in supporting, and I think give us a lot of that richness into our everyday lives that we would be very sad if we lost. Right? Okay. So we'll kind of build upon that, and so we'll ask some questions about how that episodic memory operates and why such memories can sometimes fail, and we'll talk about some ways to enhance cognition and hopefully maybe even prevent decline. Okay, and so we'll be asking this question that guides a lot of my research, which is that what if we've been looking at a three-dimensional picture? I don't have Juno here looking out over Caribbean Bay, but we've only been looking with a two-dimensional lens. Okay? It's kind of like the idea that people refer to like dogs are colorblind, so they're really only looking at sort of like arguably 2 dimensions of something as opposed to the full picture of what there really is. And maybe that's the case of what we've been doing scientifically, and I'll allude to that a little bit as a recurring theme as we move along through the conversation today. And we'll allude to this idea as well, capturing this Far Side cartoon, these 2 amoeba, right, which refers to some of the basic frameworks that we studied in memory, right? The ability to infer memory based on the response to a given stimulus. response, right? So stimulus, response, don't you ever think it's supposed to be this way, sort of nagging the husband maybe there, okay? And it's referring to this idea that if it's just stimulus and response relationships, how is that actually doing what we broadly and more conceptually consider as thinking, right? Okay, and we'll talk about some of the pre-existing brain states that are associated with that, and again, how this sort of comes back to that instrumental learning that we talked about from Thorndike. The chapter revisits with Thorndike, and things like behaviorism and even classical conditioning and those relationships of stimulus responses. Okay? Okay, so are you curious about learning more? Let's talk a little bit about the role of curiosity and what it plays in memory, okay? So this idea actually was based on a conversation I was having with some rum punch on a beautiful tropical bay in Grenada with some other memory researchers after a talk a few years ago. And so the idea was that in the news, there has been these reports of findings that say that being curious can actually boost your memory. So I'm going to talk a little bit about that study. It's from a couple colleagues of mine at UC Davis, and about how curiosity better prepares the brain for better learning, okay? By potentially tapping into the brain's reward system, okay? So now we're going to refer to these reward systems, also based upon what was referred to in the text, I believe chapter 17, a bit of 18, okay? And some of those dopaminergic midbrain sections and sort of the medial forebrain bundle projections from the substantia nigra up to the nucleus accumbens, that is, okay? Because it might be that for memory, curiosity perhaps may be its own reward, according to the Huffington Post blogs. Okay, so let's see here. Oh, good. Yes, that button there. Okay, so what Matthias Gruber had done in a paper together with Sean Ranganeth, I believe it was 2014. Yeah, because it actually came out during the semester that you were in behavioral neuroscience, and we briefly alluded to it, you might recall. We touched upon it briefly in this class as well. Okay, so during a basic screening phase, what they did is they gave people some random trivia questions. Who was the president of the United States when Uncle Sam first got a beard? Right? Random trivia questions. And what they do is they ask people how likely is it that you already know the answer, and then they also ask them to rate how curious are you about the answer. Okay, so you got these different rating levels of curiosity, which of course is going to come, we're going to double back to that and categorize brain activity and memory responses based upon that. Okay? And then things like, what does the term dinosaur mean? Just random factoids, right? Okay. So it turns out that during the times when people said they happened to be curious versus times that they didn't, saw differential brain activity patterns, okay? And it turns out that as you get higher up these curiosity ratings, okay, we saw a lot of basically activity evident in areas called the nucleus accumbens, substantia nigra, SN, and VTA, ventral tegmental area. Now, I'm assuming everybody's familiar with those areas. One, because they're from inside readings, and two, because you've all have passed with competency in behavioral neuroscience that first introduced some of these areas. Now, what we can do, and certainly what these researchers did, is make a reverse inference, which is always a dangerous thing to do, by the way. Okay, you must always make reverse inferences with caution. But the curiosity factor itself does not necessarily have to do anything with reward. But these areas, prior studies have implicated strong relationships with reward-based processing. So it seems that curiosity increases patterns of brain activity in areas that are known to be involved in reward processing. Okay, so that's a really important distinction in how we say things. Okay, because I want you guys to graduate from the class being able to represent things in the proper fashion and not have some snooty person at a cocktail party with their pinky in the air make fun of some typo that we say in the wrong way or something, okay? And sadly, they will do that. So, also, try to avoid those cocktail parties. They're terrible. People are never that fun. Anywho, so later on, they actually went in an encoding phase. So this is before learning. Now we're actually learning, study phase, right? And we have these trivia questions and answers. And it also included basically learning people's faces. Okay, now there's an explicit memory and an implicit memory factor as well here, and there's things that they don't know that they will be tested on their memory for. Okay, so it allowed the researchers to gain some experimental leverage on tapping into both different memory systems. We'll come back and revisit that, okay? And they basically responded as such. Okay, so what did the brain activity look like when they were actually encoding and learning some of these pieces of information, okay? So it turns out that people remember the information better if they first said that they had greater curiosity for it. So indeed, being more curious about information matters. How does this benefit you in everyday life? If you are reading the most boring, awful thing in the world, dare I say, have to listen even to my lectures. So awful. Even if you're not curious about it, even if you're not interested, use what we know about the neurobiological systems, and just like drugs hijack our system, use your cognition to hijack your own system. What do I mean by that? Make yourself interested in it. Tap into elevating these systems because it will help you to remember. How do you make yourself interested in it? Maybe you just tell yourself, this is really interesting, or you read it mentally in your mental voice with a cadence. Like I'm talking now, you're like, yeah, this is really, yes ma'am.
One of the ways that I do that sometimes is like if I'll go on the internet and like Google something, and you find like some interesting thing about it.
Exactly. Fine. You're reading the book. So I'm a small Cessna pilot. Well, I'm a regular size Cessna pilot, but I fly small Cessnas. Okay, so it's in the vein of saying things the proper way. In order to do that, you have to read mountains of really boring FAA manuals, and then you have to get tested on it. It's awful government bureaucracy of like huge manuals of rule books. It's dreary, but you can read it in an exciting cadence. Put a rhythm to it. Do something to make it more curious. Even if you have to start Googling something to find out why it's relevant, use it. It works. So whatever it is, worth piece of advice. Okay, so we know that, and then later, so what they did is, so here, this is just basically shows memory performance is greater when they're high, curious versus low, and then we can basically look at a subsequent memory analysis, which we're all hopefully familiar with now, and how we categorize that. We look at activity based upon later memory, particularly during the trivia questions, and we can look at whether that information was remembered or whether the information was forgotten. Okay, and when we do that, we can see that both of those reward processing centers, okay, substantia nigra, VTA, and the nucleus accumbens, okay, exhibited greater activity for times when there was successful memory versus times when there wasn't, okay? But that was only for the highly curious information, not for the low curious information, which we already know was remembered worse to begin with. So we're looking particularly for the times when they remember better, asking, well, what the heck is going on when we remember better? Because that's kind of like a cool question, right? Now, it's another cool question, what's going on when this is not? But really, they're talking about this, and it turns out the reward-based centers that we just saw some figures of on the slide beforehand, those were preferentially engaged during the actual memory, not just during that rating period, okay? So that was pretty cool, okay? Now, it turns out that they also measured that incidental implicit memory. People didn't know that their memory for those faces were going to be tested. You saw them again. Oh, by the way, happen to remember this face? All right, so they're like, well, sheesh, I don't know. Wasn't really paying attention. They're like, sweet, that was the goal. We want to know if neural systems were captured, and indeed cognitive ones, when you weren't necessarily paying attention, to intentionally and explicitly encode. Okay? So, they wanted to see if this activity here carried over to support better memory for the faces that followed. And it turns out, indeed, that was the case. Okay? And we can see that individual variability there in the curiosity-driven memory was actually supporting the anticipatory behavior and the connectivity between those frontal and hippocampal regions. Okay? So that was pretty cool too. And again, we talked about these areas being enhanced during that learning. Okay, so this is the explicit memory, and this is the implicit memory, so the faces and the questions. Okay, so both of those were enhanced. And again, the areas that were involved in that are these classical midbrain reward systems, okay? You've got the substantia nigra, the ventral tegmental area. We know that there's a lot of projection systems bidirectionally back and forth. There's this highly interconnected network of dopaminergic, GABAergic, sometimes even glutamatergic activity between this nucleus accumbens area, frontal cortex, prefrontal cortex, and then these medial temporal and midbrain areas, okay? So we can see a lot of that information, which the primer was set for those of you guys who had a chance to read the chapter and prefacing the role that these areas play in that, okay? And so the idea is that perhaps these midbrain areas, the ventral tegmental area, might be signaling to salience of the upcoming information, perhaps tapping into that curiosity network about some goal relevant information. So if you're more curious about it, it might be more goal relevant, and it is going to ramp up that network to hopefully support things. And the idea that Matthias kind of alluded to is that curiosity might be actually serve as its own intellectual reward, right? So we talked about these areas of behavioral neuroscience, all sorts of other classes about the reward processing, right? And perhaps, right, if you think about it in an intellectual way, right, it's rewarding when we find out the answers to information that we're innately curious about, right? We're just kind of adding a new way to think about memory-based and learning-based things, because we never thought about that predominantly in the field in terms of like intellectualism having like its own form of reward. But we can now use this to our advantage, how we learn about it. So, okay. So we'll talk a little bit about some of the networks that are involved in some of the base level of these pre-existing brain networks, okay, that might support these areas before the learning actually happened, okay? We'll call this the activity that's happening prior to the stimulus, right? So we go back to our little amoeba cartoon. Stimulus response, don't you think? Okay. What's happening before the stimulus? So there's got to be something beyond just stimulus and response relationships. Certainly this data alludes to that pretty clearly. And so we'll go to that pre-stimulus idea. Okay? Okay, so I'm going to zip through this kind of quick, but the idea that we've already talked about are these stimulus-response relationships, Pavlovian and operant conditioning, Thorndikean conditioning, things like that, instrumental learning, alluded to in the chapter, but we're going to build upon that. Okay? And these ideas go back to Descartes. Okay? You have stimulus on the outside. It comes in, it's processed, results in producing a behavioral response. Okay, we're going to add to this. Okay, and we've always modeled neural activity. In this case, it's a hippocampal pattern activity as differences of activity that respond as a function of the stimulus onset. Okay, we're going to broaden our conceptualization about that. Okay, because recent studies of attention and memory, particularly attention and sensation studies, very, very early sensory things, have found that brain activity prior to a stimulus does indeed play an influential response. And so we're going to ask if those types of patterns can be found in memory-based processing. And it's based a lot upon the great work of people like, God bless you, Dr. Ali Nazahiri, Steve Luck, Sadagiani, G.I.C. Benton have done fantastic things in the attention and psychophysics world. So if you're interested in that stuff, I would refer you to those studies, and I'll have these slides up there. You can grab those citations. And we're going to look to see if that's evident in memory. Okay, so it turns out that in basic ERPs, this is basically the onset of the word. And it turns out that brain activity differs as a function of a cue onset saying when a word is about to happen. And it turns out this activity is greater for remember trials, or trials that go on to be remembered, than those not. Okay, so this is during the learning phase. This is a paper by Otten et al. In 2006. Okay, and it was followed up by MEG activity, magnetic-related activity.
Could you repeat that again? I couldn't get that.
Yeah, okay, that was really fast, wasn't it? Okay. Encoding. We're learning information. This is the onset of a word. So before here, everything to the left, blank screen. But something is different in brain activity for times or words that later go on to be successfully remembered versus those that go on to be unsuccessfully remembered, that is, forgotten. Okay, so this stimulus happens here. Everything pre-stimulus looks like there's action biologically that's somehow determining what gets learned. A little closer? Okay. Same pattern was evident using MEG. Okay? And that was linked with medial temporal activity, but of course, there's limitations with those MEG approaches and social localization. So we can see some of these basic things in the learning phase. Okay? Here at UT Dallas, we are recording some EEG. Okay, this is an EEG class I teach. The students had a lot of fun hooking their buddy up to a bunch of electrodes to his head. And so what we can do is look at actual memory retrieval as opposed to the learning and encoding phase, okay? And so we've talked about item confidence ratings and their usefulness in pulling apart different memory confidence or memory processes as well as source memory. We're going to look at EEG activity instead here. Again, that idea before the stimulus onsets. We're going to categorize it based on how they successfully remember or forget the source of where that memory information came from, okay? So did you learn this from me or did you learn it from Dr. Thompson? Where did the information come from? Okay? And so we'll look for that pre-stimulus activity. When we record that, we find that right before stimulus onset, so 0-point stimulus onset to 150 milliseconds beforehand, okay, everywhere that's red here is where there's a statistically reliable difference between activity in the theta range, talked about theta last classes, between times when they went on to successfully remember versus forget the source information. Okay? Pretty wide mid-frontal, left temporal parietal areas. Okay, and it turns out that wasn't just a biological phenomena, okay, but it actually successfully predicted behavioral performance as well. So this is just looking at a snapshot of this activity at FZ. Okay, so it's a mid-frontal electrode. You can see prior to stimulus onset, this is where that action was. It's pretty cool, right? So now we're expanding beyond that traditional stimulus-response relationship, and we can see that that successfully predicted behavioral performance. So there's a real behavioral relationship here, okay? And so asking about neural substrates, I'm going to zip through this a little bit real quick. First, I'm just going to say that there is some network connections between this pre-stimulus activity in the frontal areas and post-stimulus activity in the parietal areas. Okay, so this is during the actual remembering. The stimulus is on the screen, so obviously we're remembering. Okay, and it turns out these frontal areas are pointing to the post-stimulus areas where there's a reliable statistical relationship. So it shows that there is network connectivity between here and here. Okay, which gives us a little bit of insight into some of the broad networks that are involved in supporting these types of dynamics. Okay. So I'm going to, let's see here. So, briefly describe an fMRI study that then found that some neural structures related to that as well. And so again, we're going to look at a pre-stimulus period before they fixate on an empty screen and then learn either a pair of pictures or a pair of words. Okay, now this is sort of a complicated study, but I'm just going to keep it really basic in general. And you just only, don't worry about any of the other more complicated details for the purposes today. And the idea here is just to take home that we see this broad frontal parietal network that's involved before a stimulus is even on a screen. That's involved in the successful learning of that information, okay? And we see that as well as with the hippocampus here. That's the top part as well. The bottom part is post-stimulus activity, just showing that we do see normal after the fact learning related activity. It's kind of an important thing to show, right? Okay, so, and that also predicted memory as well. I'm going to leave this stuff out for the purposes of today because it gets a little complicated, but I have actually given lectures very similar to this online, and so if you guys are interested in the details and more descriptions of that, you can either see the paper or check out the videos that I've posted on YouTube, or just email me and we can get coffee and chat and I'll talk all day about it. Is that a good trade-off? Good deal? Okay. Let's skip through these more complex events. So we talked about pre-stimulus ideas and the role that basically cortical and hippocampal areas can play, is particularly involved in supporting that reward-based processing between the ventral tegmental area and nucleus accumbens, that the Gruber et al. Findings. Don't worry about these findings, are too complicated for the current class. I'm just going to skip through these slides for purposes of time. Oh my gosh, we're almost done. Hold on. Okay. We talked about changing brain states to enhance performance. Okay. Yada. Oh, quick finding. We can actually stimulate in that same frequency band in theta, okay, in between encoding and retrieval, basically what you might consider the consolidation period, okay, and find that it also improves memory. That's what that little star is between the red and the blue boxes. Okay, this is work that's not yet published. It's going to come out soon. Okay. Side note. New paper came out today. I will forward it to you if you guys are so inclined. It's a paper we just published, me and a colleague from New Jersey, that dissociates forms of fluency and implicit memory between perceptual fluency and repetition fluency. It's a little wonky on the cognitive details on that, but if you're interested, I'll post that to e-learning too. So I just got the preprint for that like 5 minutes before class. But this is submitted right now, and hopefully you guys will see that in the future. And it turns out that if you stimulate in this theta frequency, 4 to 8 hertz, okay, you see a bump in activity, particularly again at this left temporal parietal areas that we saw evident in the earlier studies, okay? So now we took what we learned there, and we found that it actually enhanced memory if you go and manipulate that frequency, which is pretty gnarly if you think about it, right? So now we're actually doing interventions to improve memory, okay? So that's pretty cool. Let me see. Okay, so we've talked about connections here. I'm just going to post these slides to e-learning because they're basically suggestions on how to improve learning and memory. You guys will all be experts of learning and memory by the end of this semester, so if people ask you how to help your memory, you can refer to some of these slides, and it provides a lot of the summaries of what we just talked about, okay? So that's why I'm just skipping through it really quick, just so you guys all have that down, right? Okay. I want to share with you one thing here. Let me see if I can find it. Okay. Because I think it's a great place to wrap up the class on, okay? Because we've talked a lot about patient HM and these classical models of learning and memory. And what is one of the hallmark features, okay, of our textbook, and indeed the Bible of Neuroscience, Principles of Neuroscience by Nobel Prize winning laureate Eric Kandel, okay? And in fact, this is him receiving that Nobel Prize in Stockholm. This is a snapshot from his book published in 2013. This huge, is like this thick. Yeah, it's a really good book, though, by the way, for those of you interested in more advanced conversations on the neuroscience. He says, one of these textbook dogmas that's inherent everywhere else, I've highlighted in here too. He says, implicit memory, which we've talked about a little bit, all right? Implicit memory does not depend on medial temporal lobe structures. 2013, page 1463, okay? The hallmark. Now, it's not just, it's easy to pick on Eric Kandel for this, by the way, because his book is really big and prominent. It's actually not necessarily his finding or his model. All right, this goes back to Brendan Milner's work with patient HM, goes back to Sue Corkin's work with patient HM, and particularly that declarative memory model that the text talked about, the unitary model from Neil Cohen, Larry Squire, all that kind of fundamental work, okay? So I don't mean to pick on Eric Kandel, it just makes for good theater when we share the information, okay? This comes from a lot of other people's ideas, but it really is textbook in that regard, okay? But what I want to do is challenge that conventional wisdom because our chancellor indeed asked us to do that. We'll return to this idea of what we're looking at, what if we're looking at a three-dimensional picture with a two-dimensional lens, okay? Now, our traditional way of looking at implicit memory and priming, as alluded to in our text, right? Habit systems, non-conscious learning, procedural memory, and all of our traditional things. We see cortical areas, okay? We see conceptual priming, perceptual priming, and visual, auditory areas depending on our sensory modality, okay? And we can see that covered in a lot of prominent review papers and textbooks alike. Like we said, these implicit memory systems depend on these cortical areas, allegedly, that are different from our medial temporal lobe hippocampal areas that seem to only be necessary and involved in explicit memory. And I'm going to challenge that, okay? Because other people have been challenging that as well. Okay, so I want to add to what our textbook's been talking about and say that over time there's been some new findings, okay? So these are all based, of course, going back to our nice gentleman HM and his younger years, Henry Moison, okay? And people have used fMRI to see that different areas of the medial temporal lobe can exhibit differences based on memory, even beyond conscious awareness. Okay? At a very coarse level, people have begun to identify some hippocampal activity. Now, that doesn't show a necessary role, right? Which is really what matters, right? Because you can say, well, it's just sort of spreading from conscious memory or something like that. It doesn't show that it's necessary and actually plays a critical role. Now, we have seen papers from Debbie Hanula and Charm Ranganith, particularly a neuron paper that they had a handful of follow-up work, that actually used eye tracking activity, which is a really, really cool way to track non-conscious memory because you don't necessarily consciously control your eye movements all the time. Sometimes we do, right? Other times we don't. And you can measure really, 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 really fast non-conscious eye movements that can differentiate things that you saw before and you didn't, even beyond your conscious awareness. Really cool method and technique. They found that it was related to hippocampal activity and indeed deficient in patients who had hippocampal damage. Really cool evidence, okay? And there's been models, if you're interested in like review papers, that challenge that conventional model, all right? Morris Moskovich had a paper in 2008, Katrine Henk And then Debbie Hanula and Green had a paper in 2012 that reviews that, okay? But really there's been a missing gap, missing link, okay? Which is really providing strong evidence of a necessary role of the hippocampus in implicit memory, in a basic form, not associations, which is what most of these studies have done. You know, the hippocampus, remember we talked about its role as an auto-associator neurocomputationally. We want single item. Remember we talked about that in the delayed non-matched sample, how that separates from associative memory. All right, there's that missing link here. And what I'm going to do, humbly, is suggest that I'm going to try to provide it to you in 5 minutes or less. I want to spend the whole class actually talking about this stuff. It just took a lot to get here. Okay, so it's possible that these MRI methods and other methods might not be sensitive enough to detect these really subtle, unconscious things. Okay, so one of the problems in the field is that so far, none of the existing physiological studies have been conducted in patients that actually have hippocampal selective amnesia. By physiology, I'm basically referring to EEG. Mostly because it's really hard. And there's really good reasons why not to conduct it. It's very challenging. There's a lot of technical hurdles to overcome with very small sample sizes. Okay, you would never necessarily embark on that journey. But just like Columbus didn't embark to find America, right? But he was going to West Indies, or East Indies, actually. And he found the West Indies. Anywho. Sometimes if we have things available, we can make some accidental discoveries. And that's what I'll try to share with you in the next moment or two. Okay? So what if it's possible that if we use more sensitive measures like physiology, we might challenge these core assumptions of our dogma of the field? Isn't it fun to challenge dogma? Okay. Hold on to your hats. We're going to dive right in. Okay? So, we had these three previously published data sets of patients who had hippocampal damage. Remember I shared that with you before? Okay, they were doing an explicit memory task and gave confidence ratings. Okay, now remember that they were impaired from our control normal performance, but they were above our chance level, which would be this bottom line of 0. These are our patients. So they were impaired normally, but they still had a reasonable amount of memory. Okay, so they had a form of explicit memory intact, presumably based upon the parietal cortex, that we got a lot of evidence from say, Mortimer, Michigan studies that the text reviewed, and that we found this EEG activity consistent with familiarity, but impaired in recollection. So we know that this form of conscious, explicit memory is perfectly fine without a hippocampus. In humans, extending that beyond the Michigan studies with monkeys. Okay. Now, here's my challenge to you. How do we measure conscious, unconscious memories during a conscious memory task? If we want to challenge this dogma, which you guys said just a moment ago was fun. How do you overcome this hurdle? My answer is the same way that porcupines mate. Very carefully. Yeah, think about it. Okay? Here's what we did. We drew upon existing work. Okay? This is actually a figure from Kendall's book that we talked about. It's from a study published in 1998 in the big paper Nature, or big journal Nature. What you do is if you record EEG, particularly from this posterior parietal areas of the brain, you can see that brain activity differs based on information that you saw but forgot compared to new items that you did not see before, but indeed you say the same information. I forgot. I don't think this is new. Okay? So this is basically how we're going to achieve this challenge and overcome it, is we're going to look at brain activity for times in which people report they have no conscious memory. Both of these lines, they say the same conscious report to you. I don't remember. Here they're right, because it's a new item and they really never saw it before. Here they're wrong, because they did see it before, they just freaking forgot. First day of class, they said, we're not perfect. We forget stuff. That's okay. Now we're going to leverage it, okay? So what's happening here is anywhere where these differ, it cannot be attributable to consciousness, conscious memory, because they've said the same conscious memory report in both conditions. So it can't differ along that factor. And what we're looking at is anywhere where this differs, particularly in this posterior area of the brain, during this time frame, about 300 to 500 milliseconds, represents neurobiological activity of the brain remembering, even though the mind has forgotten. Okay? Now let's just dive straight into the data here for time's sake. Okay? I'm going to pass over the details of calculating this measure, but the idea here is that first, a study that did this before found familiarity activity during the same time period, and we found this posterior activity that we just looked at. Okay? So this is a study in 2010. We're going to compare that to a handful of studies to see how much we can replicate it. First, here's my data. Familiarity in normal, healthy young people. Familiarity in normal, healthy, age-matched controls to these patients that are middle-aged and still show intact familiarity. No surprises there. Old hat. You guys are experts at this. We've seen it 3 times now in class. What we want to know is this posterior activity indicative of unconscious memory? Boom, boom, boom. Show the same thing. Now it should with hippocampal patients because the hippocampus doesn't care about implicit memory according to who? Everyone. All right? Boom. What do we see? Implicit memory replicates. They don't have a hippocampus and they don't have the replication. WTF. That's what I was thinking at the time. Right? So we're going to zoom in and I'll show you the ERPs that go along with this. And this is qualified reliably by a condition by group interaction. Okay. So these are the same topographies. Normal, controls, without the hippocampus, with the hippocampus. Alright? Doesn't this look a lot like that figure we just looked at from the textbook, from Eric Kandel's Nobel Prize winning book? Actually, he won the prize. The book did. But we know that there's a lot of consistency. So we're looking at the same implicit memory effect. Alright? It's completely washed out in this group. In fact, it goes negative in the opposite direction. That's the blue difference wave. And when we plot that difference wave of the 3 patients, we see it's not being driven by an outlier due to low sample size or anything of those caveats that we talked in some of our earlier conversations about patient and sample size limitations. Okay, so it's really pretty powerful, compelling information. And so what it essentially does, I'll post these slides, but I'll skip over some of the wonky details. These are basically control analyses, but they're really cool. But I'll finish with some of the summary and conclusions, right? So we have hippocampal patients that are impaired in a new measure, physiologically, of unconscious memory, all right? Refuting the central dogma of just about every book you'll probably read at this university, and most others, about the foundations of memory or neuroscience in terms of the role of the hippocampus, right? Pretty cool stuff. And it suggests that the hippocampus might play a critical role in a form of implicit memory. So it seems that hippocampal damage appears to rewire the mechanisms by which our brain differentiates old experiences from new ones. Okay? And so in terms of challenging this dogma, it seems that explicit and implicit memory might indeed actually rely on the same system, or the same neural structures, but what I would also suggest is that they may still function in different physiological ways, right? Why can't the same chunk of tissue do 2 different things in 2 different ways? Is what I'm humbly suggesting, which is very different than the models that most of our books have put forward so far, that says different stuff is done by different tissues, right? Take that to extremes, you have phrenology. Why can't you have one chunk of tissue that does different things in totally different physiological mechanisms? That seems to be the evidence that we're looking at. But it's going to take the hard work of you guys in the next generation to, first of all, try to prove this stuff wrong, or confirm it therein. And so we have that traditional model of explicit and implicit memory depending on differential structures. All right, chapter 18, okay, basal ganglia, cortical striatal pathways for habit forming and stuff like that. Hippocampal for explicit memory. It seems like there isn't necessarily that delineation in as clear of a way as we've traditionally thought, and those models can't be sufficient to account for the data that we now have. Okay? And so I talked about the functioning in physiological ways, and we can perhaps start taxonomizing things along a different line than just consciousness as a factor. Okay? So we are, what do we have, 15 minutes left? Dude, we took a whole semester, but we're good finally. We're getting the whole time thing down, right? Okay. Why don't we give our esteemed colleagues the floor so that I don't soak up any more of their time. I am happy to talk about questions and feedback or ideas about this stuff once they're done, be it after class or office hours or whenever. You guys know my email, rdante@gmail, if you need it after class. And I'm happy to talk about that stuff. And otherwise, I really thank you guys for your appreciation. If you've had a good time in the class and have enjoyed it, it'd be very appreciative if you could fill out the course evaluations in a positive way and share that information. That'd be terrific. And I've really enjoyed the opportunity to work together with you guys for the last 4 or 5 months or so of this semester. And if I don't see you afterwards, I wish you guys a very, very good summer and career and life and all that kind of good stuff. So without further ado, why don't you guys come up and take care of that. But cool findings though, right? Isn't that cool pattern results? And there's a lot of really cool control analyses that we can talk about if people are interested in later, because they're the only way that those effects have meaning at all is because of the control analyses we do to prove it based on other things. So do you guys need the computer?
We just need to plug this.
Into this computer?
Yes.
Okay, give me a moment and I'll fix it up.